Victor,
Hello.
hi.
Hi.
How are you?
Yeah, ready to start the party. Can't
Great,
wait to
great.
do it.
Welcome to Devoxx.
Well, thank you very much for organizing all of this for us. It's really amazing job you've done here.
Have you chance to
So,
watch Friday, last day of the conference?
yes. I've watched two talks. Interesting, super cool, very nice.
Yeah, what did you enjoy the most?
Well, I enjoyed the. The speakers were really able to share their passion. That's what
That's
really
true.
matters. I mean, that's what we are here actually for, right? Okay,
Correct. The
so
floor is yours. You can start.
thank you. Okay, so is my screen visible? Tell me when I can. Yes, okay, good. So, extreme professionalism, software craftsmanship. Welcome to this talk. Let's see what this is all about. First of all, a quick introduction about myself. My name is Victor Rentea. I'm indeed the Java champion, 14 years of Java plus many other languages. Then I've spoken in a lot of conferences, and you can find my best talks on this link on my website. It's a YouTube playlist. In April, 2 years ago, I founded a community which is called Bucharest Software Craftsmanship Community, and you can see the relationship to the talk today, right? Bucharest Software Craftsmanship Community has become today one of the largest developer communities in Romania. We recently opened this community for any English speaker. So if you care to join for some free live streams every month, then I'll be waiting you there. The purpose of this community is really to to be able to share our passion about simple design, about refactoring and automated testing, but more about that in the actual discussion. Now, since April, I gave up my role as a lead architect at IBM, and I'm now fully dedicating to training and consultancy. That's what I've been doing for the past 8 years, more than 2,000 developers, 40 companies. Now, what I'll be talking to you, what I'll be discussing with you today is stuff that I've been brainstorming and discussing in dozens, I think over 100 teams in dozens of companies. Now, my normal topics of training is, of course, Java related, Spring, Hibernate, and functional programming in Java. But what I am most asked for is design patterns, clean code, and unit testing. And these are actually part of what software craftsmanship really means. Then ReactiveX and Java Performance. You can find more of that on my website, or if you care to join individually, you can find me on Teachable also. Or, of course, I'm on the social media platforms. So if you care to join, I'm posting interesting, funny stuff that I learn myself, stuff that I find interesting or funny or motivational and so on. Good. Now, let's start with a bit of history, first of all. Now, at the beginning, there were only craftspersons. Most of them were women. So I want to be very clear when I speak about software craftsmanship, there is nothing related to just men. Okay, most of them were women at the beginning. Now, they had to do everything back then, starting from hardware to testing to deploying to operations, debugging, everything. Okay, but a while after this all changed. Now I wanted to introduce you gently in some of the problems in our branch. Now, as software grew big, someone had to check that the software was still doing the right thing. So this led to the apparition to the role of the tester. Now, the tester initially we saw them. I mean, we thought they would help us, but inevitably at some point we realized that the opinions changed in a way. And I want to ask you. Did this ever happen to you? A tester come with you with a bug and you say, "Oh no, it's not mine. It's no, oh please don't, no, not mine. Can't produce." But then the tester will force you into fixing it, right? The relationship between the developers and tester wasn't the healthiest possible. Okay, inevitably somehow. Then software grew big and the deployment became another problem. So this led to the issue of the sysadmin. The system administrator is supposed to keep things stable and running. As a consequence, they hate changes. Unfortunately, it is in our job description as developers that you should be changing things. So there's a conflict here, which leads to developers not having admin rights on their virtual machines, or leads to restricted software and email scanning. But I've also seen the opposite. Developers zipping, encrypting, base64 encoding, and emailing themselves the software they needed over scanners. I mean, it's insane, right? This shouldn't happen. But then 2 weeks ago, I was training at a company, and one of the developers actually suggested something. He was joking, but he said literally, "Oh, I know. We'll make this a stored procedure, so it's no longer our problem. It's the problem of the DBA." He was joking, but the very fact is insane. Right? DBAs are actually something that were invented for financial reasons by Oracle at some point. Now, a DBA will always try to keep things inside the database under his control, right? It will be conservative. Well, where the developer will just oftentimes consider database to be just a detail. I've heard this so many times. And on the worst extreme, developers will actually throw away all the everything that relational database will give them, and instead start re-implementing it over in NoSQL. That's insane, right? Things were already working. Foreign keys, the constraints, the transactionality was already there in the relational database, but still, there is a fight in between. This inevitably led to isolated communities. I mean, there are the testing conferences, there are the database conferences, there are the developer conferences. Now, the sad thing is that even on the same island, even on the developer island, there were fights and disagreements and differences in opinion, such as differences between open languages and proprietary, like ABAP. I don't know. These were always a bit more isolated. Then the static versus dynamic languages. Oh, you're a static language developer. You're an old guy, right? Then the game developers locked up in their studios. I've trained in all of these cases, and I've seen the differences in mindset, okay? That's actually how it feels, right? Developers locked up, this is the feeling. And then came the Node.js developer that actually started reinventing everything and realizing that they need multi-threading recently. So things like that fragmented even more the developer communities. Oh, but this was nothing compared to what happened in 2010, where the web trend actually caused the single-page applications to get like a boom, like an explosion. Now, these were complex bits of software, very complex, which required dedicated technologies. And it led to some separation in the teams. Now, interesting enough, every time I find front-end team separated from the back-end team, every time the average age of the front-end team is less than the average age of the back-end team. I don't know why, but young developers somehow prefer to join the front-end team. Now, and they will end up reinventing stuff that the back-end team solved 10 years ago sometimes. And they are reinventing best practices and rediscovering clean code. Okay, wow, there is clean code in JavaScript. Oh my God, there is something like that was old. But if you ask them, they will reduce backend developers to API developers, right? I mean, they will consider them to be front-end and us to be backend, or the other guys to be backend. This is insane. This should never happen. Of course, backend developers had their own perspective about what a front-end developer can really do, right? So there were jokes on both sides. There were this harsh discussion between the both sides, which is not productive. Oh, and then came the mobile world. The mobile world, so nowadays, any business in the world needs to have an application. Okay, it's common sense. You have to have an app. And there you go, you are implementing the same user interface 3 times, typically with 3 different teams producing 3 times more bugs. Every time hitting the same problems, the same issues, the same features in 3 different languages, okay? This is insane. It's absolutely insane. And sometimes it happens even worse, even in the same very language. Let's take Java, for example, okay? So we have to fix the problem in Java, so this guy thought to use OOP. Now I have a problem factory. You feel the irony, right? I mean, even in the same language, there are different styles of writing code, like procedural style that you first learn. When you first learn to code, you are just focusing on writing functions and procedures, nothing more. Perfectly fine. But then sometimes in high school or faculty, you learn about object-oriented programming. But if you are like me, you've learned about object-oriented programming from a very old teacher. but when he presented to me object-oriented, he was like, whoa, look, I can inherit reuse behavior. Don't do that. I can override concrete methods to adjust the behavior. Don't do that either. My teacher, my object-oriented teacher, was so fascinated about what he was teaching that transmitted to me this fascination. So I joined. Every developer joins the job with this idea of, oh my God, OOP is the ultimate technology, the ultimate idea possible, right? You know why this happened? In my case, for instance, because my object-oriented teacher, object-oriented was the last thing my teacher ever learned 40 years ago. That's why he was fascinating, and he's still, whoa, object-oriented, whoa. But then you join a team, and suddenly in the team there is this geek guy who is a very big fan of functional programming and considers all of you object-oriented guys just to be obsolete. This is insane. This is wrong. What the software engineer should do is to mix those in the way to solve the problem at hand in the most elegant and simple code possible. Okay, maybe you want to build some object-oriented, maybe you want to apply some object orientation around some weird state transitions or some invariants in your system. Maybe you want functional programming for high scalability or phase processing. Okay, while for the other trivial use cases, you might rely on procedural coding style. You need to mix them all, and I discuss all of these with many teams every week. Now, for all of this, there is a single word, actually. All of these, DBAs, sysadmins, frontend, object-oriented guys, this actually means over-specialization. This means over-specialization and leads to slow projects, leads to expensive projects, to large teams, okay? Every company needs an iOS team, an Android team, and I've seen this in so many companies. And the bad news is that typically, if you are a smaller company, you won't have a lot of people in the iOS. And if that guy actually is run over by a truck, that's called the truck factor. Now, the truck factor means the number of people in a team that needs to be run by a truck so that your project is in deep problems. If you have only one iOS developer and that guy is sick, then you're, damn it, it's bad, right? But sometimes it gets even worse, because if you only focus on solving a problem in your own comfort zone, you can very easily fall in the trap of over-engineering. This guy didn't know that there was a language to build wheels in, so what he ended up doing, he was inventing his own wheel. Right? But over-engineering is the worst thing that can happen to a project due to the over-specialization. What's the solution to all this? Collective code ownership. It means that you should care for the code. You should learn all aspects of your project, not only the part that you are working on. Then, so that you can help in any area that there's a fire in. Okay? Then you don't need to delegate anymore. You are in control of everything. You get a lot of power with if you do that, but also that comes with a lot of responsibility. You need to be careful. But suddenly you are in control of the entire life cycle of your project, which is amazing. What I'm talking here about is a full stack developer. It's someone who is able to do from A to Z in a project. Now, full stack is not a binary state. You can't say that you've switched from a single stack to a full stack overnight or in 2 months. No, it's a goal, it's a journey, it's a trend, it's something that you are trying to do, okay? What it means to become fuller stack, first of all, you should not be afraid of languages that you do not know. You should not be afraid of, oh my God, I don't know bash scripting. Oh my God, no. Take your project, and every part of your project you should learn and you should master. Any kind of language or technology that it uses, you should become familiar with that. You should deepen your knowledge in those places which are more critical. If your project has big issues related to deployment, then become a DevOps expert. If your project has critical UX, then become better in UX. If you have performance issues on the backend, learn there more. So you should deepen your knowledge in the places that are important for your project. You will reuse the essential things you've learned in other places, like simple design, automated testing, security, or logging. These will be somehow, the same principle will be applicable in many places in your application, you can use a lot of acquired knowledge. Oh, and as a warning for you, don't ever claim you are a full stack expert. There is no such thing as a full stack expert, especially today with the amount of stuff that we have to learn, with the depth of the framework that we are using. Just to give you a little inspiration, a little example of what it means, just imagine just see for yourself what it feels like when you are running npm install. Let's see, so npm install. There you go. Now, it can't possibly know all of those libraries, right? I don't want to mention LPAD today, but you can't possibly know everything in nowadays in the technologies that you are using. So you shouldn't claim to be an expert in everything. Now, why do you want to go that way? Because technologies will change. Technologies do change. You've seen that every 6 or 7 years, maybe faster on the front-end side, technologies tend to change. A new shiny framework, a new trend comes to, a blue whale comes to our world and ruins everything. I don't know. Learning will keep you flexible. Now, I've worked with thousands of developers, and those developers who were still in a learning state, we're special, we're better, we're more open. I love working and teaching and discussing things with people which are learning, no matter what they will be learning. They could be running a master, they could be doing the second faculty, I don't care. If they are in this learning mindset, it's amazing to talk to them because they are open to ideas, they are flexible, they have this hunger to learn, they are in the learning state. So learning all the time will keep you flexible, and flexibility is something critical in today's world. The teams, also, I can testify that the teams that are, I mean, those 20% teams that I worked with that were entirely full stack, I mean, those teams were by far more well, that they worked better with each other. They were better friends. I don't know why. Perhaps because you can't possibly know everything, so you will end up asking something to your colleagues. Perhaps because of that. Perhaps because they were facing the same problems, all of them. I don't know. But they were a better team if they were full stack. And of course, for your purpose only, because you are more useful and more adaptable to things, you can actually earn more. You can actually be more valuable to your team and to your company. Now, being in this training and teaching business, I get this question all the time, on many places. What should I learn? Okay, I want to be better. What should I learn? The best advice I could ever give you is that you should master the technologies that you are currently using on your current project. What I mean here, in case you run into a bug, never patch over a bug. Never just quickly dirty fix it. No, every bug is a learning opportunity. You should investigate to the depth what was wrong. Perhaps it was the technical framework that was weird. Perhaps the problem was a design smell. Perhaps a bad practice that spreads in your application. No matter what was the cause of the issue, isolate the problem. Ideally, put it in your own pet project. Reproduce the bug in a separate application, and then you know what you do. Then you present the problem in a brown bag session to your colleague. Doesn't matter we are isolated. Just over Zoom. Okay, folks, while you're eating, let me show you what I found the last week. Okay, present the stuff. Only then you know that you really are mastering it. Okay. Then every time you read code, you walk through code, you don't just read code, my friend. You don't just go there and look at code. Oh my God, the code is there. No. You should constantly seek for ways to improve the code. Constantly look out for flaws in design, for better ways of doing those things. Don't ever read passively some code, but always proactively thinking, what could I do better? Okay. What will happen then? By the way, all of this will happen even if the problem or the thing that we are talking about is in a language that you didn't master yet. I don't care. The same applies. Read more in that part that causes you problem or that is specific to your project. And people tell me, oh, but my technology is obsolete. There is no such thing. The same problem that you are facing in a technology, you will be facing in other technologies as well. Okay, realize that. Okay, so learn the thing that you are doing today to the most of it. What will happen then? Then you will be able to actually fix the problem, not just work around it. Okay, so there is no more throwing the dead cat over the fence, like it's this saying. You won't pass the problem. Oh, it's a front-end problem. No, if it's a front-end problem, you will go there, fix it, and that's it. So no more passing around problems. Then, in case you have to implement a new feature, then you will be able to find the right tools for the job. By the way, did you know that you can export, that you can generate Excel files from JavaScript? Why not, right? I mean, there are things that you can do which are a lot simpler, and you should know of them. Okay, this will allow you to keep your code simpler, and this will allow you to actually focus on what matters most, which is maintainability, the ability to actually have that code in place and in a good state even after 5 or 10 years. You will focus on maintainability, not on the shiny framework or language. In simple words, you become a pragmatic programmer. You become someone who really looks after fixing the business problem. Okay, so I told you about becoming fuller stack, okay, knowing more of the languages and technologies that your projects are using, but there are other worlds around you that you should tear down. Now, developers are special. You know why they are special? Not only because they are sitting on the computer. Nowadays, we all do this, right? No, developers are special because nothing fuzzy can go through us. We are the human-machine gateway. The people that we talked to, the analysts, the business, the product owner, the users, everyone can have fuzzy ideas, can have unclear requirements, can have this vague idea of what should happen. But if we developers translate it to code, we can't possibly translate fuzziness into code. Code doesn't work if it's not clear. So we developers have a very difficult role to be like, there can be ambiguity only until us. After us, there can be only mathematical correct working bytecode. So basically speaking, our job is to translate human fuzzy requirement into machine executable code. Now, this requires a lot of interaction between us and customers. And if between us and customers there is an intermediary, like a business analyst or a product owner, then in case this guy doesn't do his best effort to help us, but I mean his super best effort to help us, then it will actually make impossible or very hard negotiation to happen. I'm not talking just about negotiating numbers during estimations. I'm talking about negotiating scope or requirements or clarifying or proposing improvements. This intermediary between us and the end customer should be extremely responsive and put his best effort to the job. Otherwise, can ruin everything. Can lead to this idea of the broken phone or Chinese whisper that the message ends up received distorted, right? And this will inevitably lead to a lot of blaming, which is very toxic in our branch. Okay, let's just an example, an old meme out there, how the customer explained it, how the analyst designed it, how the programmer actually wrote it, what was billed to the customer, and what the customer really needed. You see the difference between this and this and this? What the heck? Because of the intermediary people, the message got distorted, and we couldn't actually realize that he was actually just needing this. So what this leads to is that we end up delivering expensive bugs in a slow pace, right? And despite all of this, we still have a job. This is amazing. This was surprising for many of us. Whoa, well, we do a lousy job, we make bugs all the day, and we still have a well-paid job. What the heck? Now, developers realized this was a bit strange and gathered in 2001 for this Agile manifesto. You all should know this already, right? Emphasizing individuals, not processes, and working software, not documentation, collaboration, and responsiveness to change. Okay. Those guys that settled on these principles were the top-notch, the best developers of that day. The best developers, like Ken Beck, Uncle Bob, Martin Fowler, the best developers in the world gathered and made this. But nowadays, if you ask, I've asked for years the teams that I worked with, are you agile? And whenever I asked that, they were like, yeah, but yeah, transitioning, or yeah, kind of, yeah, agile-ish. These were actually the typical responses I got. Now, why is that? Because the developer, what is agile and how is agile sold to people? Now, unfortunately, at least in the eastern part of the Europe, to be honest, this is the typical answer I get. Agile-ish. Why? Because business is being sold to the business as a way to increase velocity and adapt to late changes. They can change their mind. And of course they want it. Who wouldn't want it, right? So this will lead to a scrum pushed upon us. Okay, this is what I've seen happening in dozens of companies. Okay, from higher management comes that we need to transition to Agile, with the digital transformation, okay? And they will be Scrum pushed upon us. And in all of this stuff, just please remember that Agile is not a magic creature that eats post-its and produces software, okay? This is not Agile. Agile, it was all about excellence. It was all about, the developers that actually brainstormed that manifesto were the best developers in the world. Excellent developer. Where is technical excellence? People realized that something was missing from this game, and in 2008 they gathered for this software craftsmanship manifesto. This actually introduced the term of software craftsmanship. They were saying that working software is not enough because that might be shitty software, full of technical bugs and lousy code. This is not enough. We want well-crafted software. But I know what you'll answer me. Oh, but we don't want shiny software. Today we need to move fast. We need to go to the market and see if our product actually fits in the market. I know, I understand that. But tell me honestly, have you planned for a 2 weeks or 4 weeks refactor after 2 months of rushing? Have you planned for that? Or are you planning to rush for 2 years in a row? Guess what will happen after 2 years of rushing? Just imagine the technical debt you will have after 2 years of rushing. So my point is here, you need to balance. You need always to take this into account, and whenever you are rushing, know that you are gathering, that you are piling technical debt. Now, they also said it's not enough to respond to change. This is just a reactive behavior. We want to add proactively value. And this is actually one of the strongest weapons that you developers have to earn the trust of your customers. Every demo you have, every chance to talk to the customers you get, you should prove to them that you are partners, not just collaborators, that you want the good of the software. In practical terms, you should propose improvements to the software. You are the first developer, you are the first people in the world who see the software product. You have an enormous advantage. You can see what, you can propose improvements. You should go to your customer and tell him, look, if I were the user of this application, then I would like these features also. Don't implement them for free, but propose ideas to your customers. This will earn their trust, and then you can actually ask for time to refactor because they will trust you that you want the best for your project. Okay, and individual interactions weren't enough. They needed professionals. Professionals were required. Right? And I would like to do a parallel with the most respected profession in the world, the medic, the profession of medics, right? You know that they take an oath when they graduate, not to harm a human being. How about us taking an oath, like I will not commit garbage, or I will push with reliable tests? Okay, how about that? But by the way, if you think of it a bit, these two medics are actually telling the same thing, that they will not harm a colleague, because tests with code with no reliable tests and lousy design will end up hurting you back, you or a colleague. So how about taking an oath about that? Okay, good. Okay, so a code of ethics. Okay, I can get that. But what should I do in practical terms? Now, you as a craftsperson should be able to talk to the customers, but I don't mean that. In many companies, you don't have the chance of doing that. But every time you are given the opportunity, you should have the necessary communication skills to explain their problem to a non-technical guy, or to communicate or to understand actually the real underlying problem, not the imagined solution. No, the real problem. What's there really? What annoys them or what they need really? And then propose solutions. I know that you might not be in the solutioning teams. Many large companies have separate solutioning teams. If this happens to you, go to them and kindly, humbly ask them, oh, please explain me, with a very modest and open attitude. Please tell me, why have you chosen to use Kafka there? Why have you put there that NoSQL? Why are you using Cassandra, and why not a relational? Ask them this. You want to know why they've chose the technical stack that you're currently using. So don't be afraid of asking them gently and kindly, okay? Then Also, you need, this is a separate skill, the ability to take a problem and break it down into smaller user-centric stories so that you can get feedback and you can get paid for those, okay? That's a hard skill that's a difficult skill to master. So as a hint here, if you are among the people who are estimating the stories and you are not doing it together as a team, just take some of the developers into the party and explain them why you are doing this, why you are breaking it like that, why are those tasks interdependent, and so on. You should grow this skill into every of your team member. And every one of you should be able to design wireframe and screens. In my experience, you can you can clarify 80% of the requirements of every project if you have the screens drawn. If you have the wireframe, if you have the screens somewhere drawn, then based on those drawings, you can have 80% of the requirements clarified. Because people reason better if they can relate to a screen. This human nature, they can see buttons and text field. Oh, that button should be there or should be disabled. These kind of questions you can find, you can solve if you have the screens. Of course, you should be able to write working code. Of course, but then you should also be able to write tests that will avoid you, that will keep you from introducing bugs when you refactor. And refactor you should do. You should evolve your system architecture to meet the new functional requirements. You should be able to adapt and to evolve your design every day without being afraid of introducing bugs. That's the purpose of automatic testing, really, to allow you to refactor every day, every single freaking hour. And then if the development team, if the DevOps team is just sick one day, then you should be able to take over their job. You should be able to push the production. You should know some things there so you can fix issues there. Of course, you might not be as effective as the DevOps team that you might have, but you need to know that part also. Okay, now a classic developer, a classic software developer will only write working code and sometimes even refuse to do any other job that you might ask him to do. Okay, this is bad. This is very bad. Now, what I'm asking you here is to try to do more than just writing code. Try to learn more about what other phases in your project are there. Try to learn other parts of what it means to build a software project. Now, accidentally, somehow, my main focus of my training, I'm really actually focusing on teaching people how to write effective automatic testing and how to evolve an architecture and how to refactor and how to redesign stuff. Now, and I want to give you two ideas from these areas, testing and refactoring. Now, the first one is about testing. I want to quote from a book that I love. Back in the 90s, debugging skills were a major point of discussion in any job interview. Seniority could be measured, breakpointing. Okay? Seniority could be measured by how good you were at breakpoint debugging. Those days are gone. Nowadays, you should be disgusted, unpleasantly surprised when you need to rely on those skills. Although you need to have those skills, you should be disgusted when you need to rely on those, like breakpointing, step into, step out to. Instead of doing that, you should immediately write, test, and refactor code such that you never need to go that ugly path again. Okay, so don't fix bugs just by breakpointing. Take the time to write an automated test around it so that you can fix it for good. So I don't want you to be clicking the mouse, looking in the logs, and perhaps the third time you get the bug back at you. No, debugging sucks. In comparison, testing rocks. So this means you can fire those tests every single commit, every single hour. And of course, Jenkins should be running these all the time. And in case you have tests that don't run on Jenkins, those are no tests. The tests that don't run on Jenkins do not exist. Do not exist. And the other point is about refactoring. Now, sometimes refactoring isn't enough. The whole extreme programming and software craftsmanship ideology goes towards the idea of evolving the software, of evolving the design. But what if the architecture never emerges? What if you never end with a well laid out architecture? What if you are just running and piling up a lot of garbage, without any design? What do you do then, and why does it happen? First of all, you might be lacking the knowledge about what you are building. This is natural in an Agile application. You might not know what the next requirement will be. That's inevitable somehow. But also you might have maybe half of the team could be junior, completely junior. Okay, then this could happen to any project. But the solution to fix this actually is applying the correct practices to this scenario. I mean, what you're really missing are practices. I'm talking about here about pair programming, about test-driven development for the most complex parts. I'm talking about continuous refactoring, about simple design, collective code ownership, the practices of extreme programming, really. The extreme programming practices, and it's time to note that extreme programming doesn't mean you should code while skydiving. No, extreme programming really means extreme professionalism, right? It means a code of ethics. And there is actually an attempt to define a set of rules to follow if you want to name yourself a software craftsperson. First of all, I shall not produce harmful code. Okay? Then the code that I produce will always be by my best work. I will take pride in the work that I produce. Okay? When was the last time you felt pride about the code that you wrote in a day? Okay? You should feel proud about your code. I will make frequent and small releases. Okay? No 2-month-long feature branch. I will provide with a quick and repeatable. This actually means automated testing. I will not fear the code, and I will relentlessly improve the code structure at any occasion. I will not increase the technical debt. I will keep productivity high, meaning that I should automate as much as possible. I will ensure that others can cover for me. How could others cover for me? It only means actually one thing: pair programming. I should pair programming so that when I'm sick, someone can take over my task with no fuss. Okay, I will produce sharp estimates, and I will never stop learning and improving my craft. We could spend a day talking about these points, but I want to focus on this one. However, you should never stop learning and improving. Now, I know what it feels. It feels like the performance. You need to push code every day. You need to fix bugs. You have deadlines. You have risks. Okay, you need to perform every day, and this doesn't leave you room to make mistakes. You can't possibly put a bug to production just to learn something from it. It's not ethical. It's like you're always on stage. Then how? And then when do you learn? When do you get yourself time to learn? Now, I want to challenge you. First of all, to challenge your design. To try to make your design in such a way that it becomes easy to test. Make your design testable. And the way to challenge this is to attempt to write reliable tests on that piece of code. Then, in case you are a backend developer, try TypeScript or vice versa. Then try SQL. Maybe try Clojure if you know all of the other. Try Swift. Try another weird language that will move your mind. I mean, change the perspective that you have. Okay, I look different at code today after I learned Scala, for example. Okay. Then challenge your communication skills and try to explain the technical issues you have to a colleague. Every day you should be talking and discussing about code. You should be able to express a technical issue to any colleague with very much ease. Even to non-technical, you should be able to explain. Challenge your reasoning and maybe start a pet project to notice the trade-offs, what should be done and what should not be done. Or even maybe think about starting a business to get a feeling of where the money will flow and what's the actual real cost of a software project. But all of these are, let's say, second stage. In my training experience, I've seen many people struggling on getting past these phase. And this is actually, this is where the need for a coding exercise comes from. You need to practice. Remember what the book says, and I will really advise you read this book. It's an amazing book about how you can drive your professional career. Now, what's missing from all of this is the ability to play. And I keep repeating this. What's missing to our profession is the habit of playing around, of experimentation. I want you to be doing coding exercises. These are actually named coding katas. These are not production code. These are synthetic exercises designed to teach you something. When you solve such an exercise, you should not rush at any moment. You should feel safe. You should not be stressed by, bugs and deadlines and so on. You should aim for perfection all the time. Perfect code that you are proud of. You should reflect on how you work and always try to get you out of the comfort zone. If you are solving an exercise using the identical techniques, the same coding style that you are using while you are coding for work, then you've missed the point. You should try to to get you out of the comfort zone. Then you can gather more of you in a coding dojo. And I've been doing, I think, more than 100 coding dojo in different companies when I'm teaching clean code. And it's very, very interesting. And I always encourage them to do them, to repeat this exercise after I leave. You only need around 4 or 10 developers for a time box of several hours most. And during this coding dojo, so there are many developers solving the same exercise together. You need to practice pair programming, practice refactoring or test-driven development. Never rush, never fear, there is no room for competition. You should not compete each other. But what you need to do is to play, is to experiment stuff, is to try new ideas, and always remember to challenge your skill set and try to solve the problem the other way. Okay, the other way. Now, here are some books to get you started. In case you are entry level in clean code, I would highly recommend this book with pre and after. I mean, code, ugly code, good code, commented out why it changed. Then this is the book for exercises that you can take. Read the first half of this book and chapter 3 from this book at least, and following the links for the code smells that you recognize from your own production code, and read from there. And for exercises, this is an amazing book I've used for years. Excellent book. Now, you might be practicing as much as you want in synthetic exercises like sandbox, playing around, but nothing compares to learning on the job, and nothing compares to learning in pair programming. Like one guy is writing code while the other is watching for higher level ideas and design and sync responsibility principle and looking out for highly coupling code and so on. Amazing experience, and every 10 minutes you swap. Okay, there are some rules. If you want to discuss more about pair programming, join the Zoom room I will open after for the discussions after this session. I have some tricks to share with you about pair programming. These tricks. Just enumerating them. It's fun. It's way more fun to code together with someone. You get better design because the navigator that just sits there and look at the code is just watching over big picture. Okay, you get less bugs, and this will interest your boss when you will tell him that it's actually faster and cheaper on the medium long run. Apparently, there is a demonstration on this site that on the medium long run is cheaper. Pair programming is cheaper if your project is supposed to live for several years, because there will be half the number of bugs and you will get better design as a result. Okay. Then more passion, because yeah, you are two of you. If you are coding alone, especially in these days, you're like, maybe someone will, maybe your child or your spouse will enter the room and ask you to go and shop something. You're right in the middle of the work. If you are talking with someone, they won't dare to do that. Okay. So natural knowledge flow, because it's easy to learn something from. I mean, it's more natural. You are working together, and when you are coding together with a senior, you will notice how he codes, and okay, super easy to learn. And easy to reuse because you've seen the code that you did not write. You've seen the code of the other developer. It's a collective code ownership, actually. Team bonding, you work together, you work together all the day, okay? Nice. Now, this actually I want to introduce to you my dear pig. Now, this is a real pig. Look, can you hear? This we call this the pair with me pig. Now, this was useful when we actually worked together physically, but what was the point? It's very interesting. Whenever someone had a problem, okay, and that problem exceeded his skill set, then he would squeeze the pig. At that precise moment, someone else who was just rubbing mint, doing nothing, will come and help that first guy. Now, we weren't officially planned and encouraged to do pair programming in the projects that I led. So what we did instead, and actually, to be honest, the kind of projects that we worked on weren't suitable for 100% pair programming the entire day. So what we chose to do instead is to have this convention. Whenever someone runs into a problem which is just 1% above his skill set, he's just a bit afraid about, just 1% above his head, then he will squeeze the pig. And someone will come and help him. And sometimes the problem was too difficult for those two together, and they will squeeze again, leading to trio programming, and squeeze again, until it ended up with what we call grape programming. We invented grape programming. I lost the picture. I had a picture with us doing this at one point. So this happened to us maybe once per month. One famous time, the last time I remember, it happened when a colleague of ours were playing with Eric's GS in Angular, and we were just puzzling what they were talking about, and we piled on their back and discussing stuff. We never heard of these things before. And whoa, what was that? Super interesting. So ad hoc mobbing. Now, pair programming, refactoring, unit testing, all of these are supposed to increase your desire, your passion to write code. But as we've discussed, craftsmanship doesn't mean just loving the code, but it usually starts with that. That's why I insist on emphasizing the will, the joy of writing code by writing exercises, by writing tests, which actually represent more code. Oh, joy, more code to write, more refactoring to do. Okay, so you have to take this desire of writing code and use it to its most, especially if you are at the beginning of your career. It is mandatory for juniors to be eager to write more code. It is normal. This is how the things are supposed to be. So when you first join this profession, you should just be willing to write as much code as possible, but then you realize, then you are a bit puzzled that seniors will be so eager to delete the code. And I was puzzled, why? Because seniors know that the code will hurt them back. Seniors know that seniors spent dozens of nights debugging shitty code. Seniors know that code hurts them. So if they can delete some code, they will. But don't be influenced by them, you that are starting your career. Write as much code as is necessary so that you are comfortable with design and writing and solving a problem in a language. Master one language first and then move to others. After you've mastered 3 or 4 languages, then any other language won't be a mystery for you. You will recognize the same ideas over and over again. But the seniors that think this, they are actually, they have this perspective that perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. If you can solve a business problem with no code at all, perfect, no bugs. Okay, so perfection is when you implement when you solve a business problem with the least amount of code. And this is actually my message to you. You aren't hired just to write code. You aren't supposed just to be writing code. You are supposed to solve problems. So my message to you is step out of what you're currently doing. Look around you. Look what happens before you get your task. Look what happens after you ship your task. Look around you and try to learn more of this. You should never spend a week without learning something, okay? And in the end, after years of learning, you will realize that we don't just write code, but we solve problems. Thank you. In case there are any kind of questions, maybe now, maybe in the Zoom room, but that's what I wanted to say to you.
Thank you very much. Hi. Thank you very much for the talk. Very inspirational. I wanted to start coding thanks to your talk.
Yes.
Yeah, after the Devoxx, I will start like tomorrow. So great.
Start with a game, by the way. If you ever plan to start coding, start by coding a game.
Okay.
Start by coding a game in JavaScript and TypeScript and something easy so that you can have visual feedback, and it's the funniest, the most engaging way.
What would you recommend? Which game?
Any game. Tic-tac-toe. I don't know. A simple game. Super simple game.
Great, great. Okay, thank you very much. So after this talk, I invite you to join our Q&A session. So you have a link in your chat. You just go by the link, and guys which were following your talk will ask you, I hope, a lot of questions because it's quite inspirational, interesting. I wish you a happy day for today, and thank you for joining Devoxx, and I hope you will come back to us next year, and we will see you offline at Kiev in our conference.
Okay, sure, for sure.
So have a great day.
Thank you very much. Thank you.
Thank you.